In this video, we will understand forward propagation or feed forward of artificial neural network. This is a simple diagram where we have four layers. The first layer, layer 1, is the input layer, which consists of three neurons, x1, x2, x3. You can consider them as the input layer because it is mainly the features of the data set. And we want to achieve this forward propagation through the technique where we will be calculating the neurons based on x1, x2, x3 for the remaining layers, that is layer 2, layer 3 and layer 4. This is called forward or feed forward because we will be moving in the forward direction. We will be going forward. We will be calculating all the neurons of layer 2, A1 to A2 to A3 to A4 to A5 to. And just to remind you that these numbers are given very based on very simple nomenclature. The 2 into the brackets refer to the layer number 2. 1, 2, 3, 4 in the subscript refers to the neurons number. This is first neuron in the layer 2. This is second neuron in the layer 2. It's like similar way that this is third, this is fourth and fifth. Based on this x1, x2, x3, we will be calculating a1 to a2 to a3 to a4 to a5 to, and as you can see, each of the neurons of input layer are connected to each of the neurons of first hidden layer, that is layer 2. So we will be calculating the neurons of the hidden layer from the input layer x1, x2, x3, and based on the values we derived, based on the values we derive for layer 2 or the hidden layer 1, we will then need to calculate the values of neurons of layer 3. Now again, layer 3 has 5 neurons, A13, A23, A33, A43 and A53. The same logic is applied here. This is third layer, so superscript has 3 into the brackets and neuron numbers are shown as 1, 2, 3, 4, 5 as the subscript. Now we want to derive the values of the neurons of third layer, and that we will be doing with the help of the neurons of layer number 2. Here you can consider, or you can say that the values of neurons of layer number 2, A1 to A2 to A3 to A4 to and A5 to, can be considered as the input for calculating the values of neurons of layer number 3. So you can say that in this case this will be your x1, similarly this will be x2, x3 and so on. Finally, we want to get the output. We want to predict something based on the input we had provided, and we are again moving forward by calculating the values of neurons of fourth layer. This is our output layer, and the output layer values or the output layer neurons are A14, A24, A34 and A44. These four neurons are the final neurons, the final output variables, and we will need to calculate them based on the values available with us, that is A13, A23, A33, A43 and A53. The whole idea is to calculate the values of the output layer neurons, and we will be processing the data through the hidden layers. To take this further, let's take one example and see the formula how to do this. So this is very basic diagram having only three layers. The first layer is the input layer, and the second layer is the only hidden layer, and the final output layer has only one neuron, that is the h theta x. For the simplicity, I have already added the bias unit which will be our x0. So whatever you are seeing here is nothing but it's your x0, and its value is set to 1. For understanding and for simplicity, all the neurons of layer 1, which is input layer, are connected to the units of layer 2, the first hidden layer. Now here the color code is used to differentiate how the things are connected in this diagram. So the first neuron, which is x0 of the first layer, is connected with all three neurons of layer 2, A12, A22 and A32 through the green color arrows. So the connection between the X0 and the 3 neurons of layer 2 are in the green arrows. Similarly, X1 is connected with the A12, A22 and A32 using the red color arrows, and X2 is connected with all 3 neurons with the blue color arrows. Remember that when each neuron is connected to the another neuron, there is a weight which is being carried by that line, by that arrow, and that weight is represented in corresponding boxes. For all the green connections, the corresponding weight is shown in the green box, while it's in blue box for the blue color arrows and red for the red color arrows. Now if you see the formula, the first formula which is given there is to calculate A12. Now calculating A12 is basic and very simple. For calculating A12 you have 3 inputs, X0, X1 and X2, and these 3 inputs have different weightages. As you can see, the formula says that uh, the multiplication of the neuron and the corresponding weightage connecting to A12 has to be added. So as you can see, X0 is connected with A12 and the weightage is theta 101. So the formula is theta 101 into X0. So this term refers to this part and this part because these two are multiplied while they are connecting to the A12. And if you see the second term, that is theta 11 x1, I will use a yellow pen for that, and this is nothing but it's the theta 11 shown here, and this is x1. And the third one, which is shown as theta 12 x2, which is also nothing but it's the line connecting the x2 and a12 using theta 12. So this is theta 121 and this is x2. So in short, you are multiplying the weightage of corresponding connection with the input variable, and the whole summation is nothing but it's your z, which we used in logistic regression to calculate the sigmoid function. So if you put this together, this will be g of z, and this z refers to the value theta 10 x0 plus theta 11 x1 plus theta 12 x2, and similarly you can derive a22 a32. Now talking about the final h theta x, we have to calculate the h theta x based on the layer number 2 because layer number 3 can be calculated using layer number 2 values. And this h theta x is nothing but it's basically a13 because you are in third layer and there is only one neuron. The formula starts with the bias unit, so let us add one bias unit to the diagram, and this is nothing but it's a0 of 2. It has to be closed into the brackets, so it's a0 and 2. Now the corresponding weight which is connecting a02 to h theta x will be the theta 102. Now if you apply this formula again in the same fashion like we did for a12, a22 and a32, this is the sum which is being calculated having the different values for different neuron inputs and then the multiplication of them with the weightage. So just to summarize what we have done so far in the forward propagation, we have calculated A12, A22, A32, which are the components of the layer number 2, and at the end we calculated the final component, which is the layer number 3 component A13, or its equivalent to h theta x. Just to add to this, please remember that when you have multiple layers in the neural network, multiple hidden layers in between the input and output layers, this formula keeps going on, uh, and it can be extended further to calculate the final output variables.